Hello everyone, welcome to the Study IAS exam, and today again we have come up with one more important topic, India's nuclear journey. We'll make them Atmanirbhar, Shantipurn, Surakshit and sustainable. So when we talk about the India's nuclear journey, we talk about the three-stage nuclear program. So India has a three-stage nuclear program which has been given by Dr. Homi Jehangir Bhabha. Okay. Why the reason is that because India has a very limited uranium, but India has a large thorium reserve. So our program ensures energy security for thousands of years. So we have created a three-stage nuclear program in order to make energy independent in the future. So what is all about India's three-stage nuclear program? So in the first stage, which we are running right now, and recently we have moved to the stage 2. So the stage 1 we are utilizing pressurized heavy water reactors, that we call it as PHWRs. Okay, in that we are utilizing natural uranium as a fuel, heavy water as moderator and heavy water as coolant. Okay, so in this reactor it produces power which generates electricity, and at the byproduct it creates plutonium 239. Okay, so these reactors are in Tarapur, Rajasthan, Kakrapar, Kaiga, Kundankulam. Okay, so the stage 1 is running right now. When we move into the stage 2, which we have recently got the criticality, we are utilizing fast breeder reactor. Okay, so the fast breeder reactor we are utilizing the byproduct of the stage 1, that is plutonium from the stage 1. In this, we are using breeder as uranium-238 and coolant as sodium, right? So now it breeds more plutonium than it consumes. That means this whole process is itself generating more plutonium than it consumes. Like there is a prototype fast breeder reactor in Kalpakkam which is generating 500 megawatt of electricity. Then Bharat fast breeder reactor is in development stage which is generating 600 megawatt of electricity. Now we are moving into the third stage, which is focusing on advanced heavy water reactor, that is AHWR. This is using fuel as thorium, in which India has abundance in thorium is the reserve which India is having maximum in the world, which is around 6,40,000 tons. Okay, so here the fuel they are using as thorium-232, breeder as uranium-233 and coolant as heavy water. Okay, so here the thorium is converted to uranium-233 and is used for the power generation. So advanced heavy water reactor is in development stage of 300 megawatts. So this is a three-stage nuclear program which India is running. So if you can see here, three-stage where we are utilizing, now we are seeing in a form of a pictorial graph, natural uranium U-238 or U-35 we are putting into the pressurized heavy water reactor. It is generating electricity. Then it is also generating spent fuel and plutonium-238. Then the second stage, fast breeder reactor, where we are utilizing plutonium-239 from the first stage and we are sending this to the fast breeder reactor, which is generating more and more of plutonium-239 and uranium-238. And in the last stage, where India is having the highest thorium reserve in the world, we are utilizing thorium-232 and uranium-233 as our moderator, and it is generating electricity. And this is India has a three-stage nuclear program. Okay, thorium is converted into 238, which is used for clean water energy, right? So nuclear resources in India, if you see, India is having the highest reserve of thorium, which is in the monazite sand of the Kerala, around 6,40,000 ton, that is first in the world. Then India is having uranium reserve of 81,000 ton, which is 8th in the world. Okay, so that is why abundant of thorium in India, greatest energy security advantage in India is having. Okay, so what is the advantage of nuclear energy? First of all, it is having high energy density, huge power from a small amount of fuel, low carbon emission, almost zero greenhouse gas emission, dependable and reliable 24/7 base load power, less land usage, more power in less land compared to solar and wind. Then energy security, which is using domestic resources like thorium. Then economic growth, support industry, jobs and clean development. But there are few issues and challenges related to the nuclear power. Radioactive waste is management because safe disposal and long-term management requires proper waste disposal. In the starting, the high initial cost because we require large capital investment and long gestation period. Then nuclear safety and security, strict safety protocols and protection from the threat. Public perception because there is a perception among the about the nuclear power and nuclear disasters. Then technology and fuel cycle complexity. So advanced technology and skilled manpower is needed. So if we go and compare India in the global nuclear context, so USA has an installed capacity of 1,02,209 megawatt. 94 reactors are there in USA, which is sharing the world capacity of 30.3. Then we have a China, which is having 81,997 megawatt of electricity from the nuclear. 57 reactors are working, which is 17.5% of the world capacity. France is having 63,130 megawatt. Number of reactors are 56. Share in the world capacity is 18.7%. Russia is having 28,700 megawatt of electricity generated from nuclear. 36 reactors are there, which is sharing 8.5%. Japan is generating 13,282 megawatts with 10 reactors and 3.9% share in the world. India is having an installed capacity of 8,180 megawatt. 22 reactors are there and we have a 2.4 generation capacity. Okay, so India is steadily climbing the global nuclear ladder because 6th largest nuclear power producer, 3rd largest under construction, indigenous fuel cycle capabilities are there, thorium leadership under the stage 3, right? Now, what are the concepts that you need to remember? First of all, you know India has a 3-stage nuclear plant. Then uranium, we go to plutonium, then we go to the thorium. Then thorium superpower, India is the largest thorium reserve. Atmanirbhar Bharat, because indigenous technologies and our indigenous fuel cycle maintenance we are doing. Peaceful use, we have already said to the word. Safety first, strong regulatory framework by Atomic Energy Regulatory Board. Then future ready, SMR, advanced reactor and clean energy resources, and energy security in nuclear power ensures a strong, self-reliant and clean energy fuel in the world. So there are some of the institutions are there which are working toward nuclear power. One is DAE, Department of Atomic Energy in India. NPCIL, Nuclear Power Corporation of India Limited, which operates nuclear power in India. Bhavani is a fuel cycle and reprocessing center. BARC is Bhabha Atomic Research Center, that is a research and development of nuclear science and technology. Atomic Energy Regulatory Board ensures safety and radiation protection. So government has come up with the various policies of the nuclear power. So National Electricity Plan that target 22,480 megawatt by 2031 and 32. Then we have a long-term vision of 1 lakh megawatt by 2047. We focus on indigenous technology, thorium utilization and SMR, right? So recently there are a lot of new achievement that India has achieved. 500 megawatt of pressurized fast breeder reactor. India became the first country to commission a prototype fast breeder reactor. Then Bharat fast breeder reactor design progress, 600 megawatt of indigenous fast breeder reactor with advanced safety features, construction plan. Advanced heavy water reactor, indigenous 300 megawatt thorium-based reactor design has been there, a global first of its kind. Nuclear power capacity milestone, India has a installed capacity of 8,000 megawatt, target is 22,480 megawatt. We are also generating small modular reactors of 220 megawatt SMR design ready, and global recognition. India has technology and safety standard accepted globally. India is moving towards becoming a nuclear technology exporter in the near future. So, thank you so much for viewing this lecture. Please share this with your friends and also share with those who are knowledge hungry people, and please do subscribe, like and follow. Thank you.